All right, welcome everybody to Laboratory Order Management, last session for the afternoon, and your speaker will be René Spronk, our trainer at FHIR.
Let me try that again. Right, thank you. And yes, order management. If you were at this morning session or this afternoon session on messaging and documents, we also had some discussion around the workflow there. So how do you actually manage the workflow of a referral or an order, let's say for a laboratory test? And in this presentation, I will actually be using the laboratory orders, order environment and the results reporting as an example. And why lab orders and lab results? Well, we all of us know something about that, even if just as patients, right? We all know that, or you go to a GP perhaps, and they have this paper order form, if it's not already electronic, with all the boxes and the check boxes, and they go like, oh, potassium and a white blood cell count and a red blood cell count. We all know how that works. And then you go somewhere and they draw a specimen and it has a barcode on it and tests are done, and then you get a bucket load of observation values. So because all of us as patients are familiar with that kind of workflow, we'll use that as an example. So the aim here, the learning objectives, is to understand what's at the heart of workflow management if you're trying to do this in RESTful FHIR. Yes, you can do FHIR messaging and all that sort of stuff, and you can also do workflow with that, but the main focus here is on how would we support order management and results reporting using RESTful FHIR. Now, there was a poll associated with this session in Hoover, which you may or may not have seen. Most of you haven't seen it, because there is only 6 responses. But most of you at least says, well, we have to use this order management stuff between multiple organizations. And that makes life much more interesting. And within one single organization, I'm guessing that it's still mostly HL7 version 2, and it's probably going to stay that way for a while. So order management, if we look at that in the FHIR space, then it's an example of what FHIR calls a request event workflow pattern. That's sort of a fancy way of going like, well, first we have the phase where we're going to order stuff, and then it's done, and then we enter into the event phase when we actually are doing the requested activity. So the request in this case would be our laboratory order, and the event would be the lab result, if we were to use that example. An event, by the way, need not be done based on a prior request. Like if I'm a nurse and I observe that the patient may have a fever, I will basically observe that there is a fever, but there has never been an explicit request to actually do so. So events need not always have a request at their basis. Now, if we look at this from, strangely enough, from a workflow perspective, so how does this order and event reporting actually work? Then these are the types of systems, they're actually abstract functional names, that we have in this workflow. Well, we have some software application that has the capability to create a lab order. And here we have the lab system with some sort of software application that has the capability to fulfill that order. That's all rather abstract because we're trying to standardize the workflow of the workflow pattern here. And the trigger is some sort of software application that passively listens for the status of the overall workflow, and this represents the actual lab equipment that does the test on, let's say, your test tube with full blood or something. So normally you would go look at this and go like, okay, so we have an exchange here of my request. And that's called a placer order because that's the thing that was sent by the placer. Then they insert the test tube with the barcode in our lab equipment, the automation manager, and the automation manager will then ask the order filler, what am I supposed to do with this test tube, right? Because these are so powerful nowadays, they can do lots of different tests. So you first find out what am I supposed to do with this, you create a test result which is validated in the lab system, and then the result is forwarded to the tracker. The tracker passively listens for updates and the status updates on the workflow. Now in real life, you may say, well, if you're ordering something, you probably also are interested in the result. So these two parties, these whose roles more or less are always grouped. Well, they need not always be. Like you could have an order management system, but then the result needs to go to the EHR, right? So sometimes they're separated, which is why in this, hey, this is standardization, so you tend to abstract away from real life scenarios, right? So this is probably fits with your understanding of the type of workflow that we're dealing with. So how does this look in FHIR? Well, basically, following this request event pattern, we've got two core resources here. And one is on the placer side, we're talking about a service request. So the service request as a FHIR resource allows you to identify, I want to have some service done. And the actual thing that you want to have done is in the code. So there is some terminology, could be LOINC if we're talking about laboratory. It's a reference terminology for laboratory. So I want to have this LOINC thing done, and I can also have an identifier on there that's a so-called placer order number. That's my reference number for this requested service. On the other hand, and this is actually something that's managed and authored by the lab system then, we have the observation FHIR resource. And the observation is a very generic FHIR resource, but at its heart it has code and value. Code to indicate what am I observing, potassium, and the value that then is the value for the potassium, let's say 22 millimoles per deciliter or something, right? Now, if you look at the remainder of this, FHIR is all about resources and references between resources. So both this request as well as the resulting observation have a reference to the patient and the specimen. Right? In laboratory, we mostly do testing on specimen and not on the patient themselves. We also have a requester reference here from the service request. So that's the ordering party, which could be one of those, mostly practitioner, but could be the patient themselves, for example. And the observation is performed also by some party. So we have another reference to a FHIR resource. So these are the two key FHIR resources if we're trying to support this request event pattern. Now, quite often, you actually have a slight variation of this. So, yeah, we have our service request. I want you to do a lab test 1 and 2. And then it goes to the lab, and the lab looks at this and goes like, well, yeah, but you cannot really interpret the result of test number 1 correctly if we do not also do test number 3. So you're asking for 1 and 2, and we're going to do 1, 2, and 3. So what we're effectively doing is kind of translating the service request from the placer, this one, in our own service request. And this is called a filler order. So it was created, it's an order created by the filler, the lab system themselves. And then, based on that particular internal order within the lab system, you could say, we then create the observation for tests 1, 2, and 3. 3 different observations. Probably. Right? So you have a placer order and a filler order depending on who has created the request. Now the thing with REST is that REST basically says store. So if you send the service request to a RESTful server, then the RESTful server will go like, oh, thank you, archive, done. And you go like, no, I actually want you to do it. But that's not what REST is all about. REST basically says, oh, resource in, and if you do a get, resource out. That's it. It's a passive store. So if you want the receiver to do something, you need to have a bit of trickery around this. Now it could be, number 1 on my list, that you have kind of a prior agreement with the system. If I send you a service request resource, then implicitly, nudge, 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 you're supposed to actually do it. That's implicit. But we mostly don't like that because you can have mixtures of implicit and explicit, and then what am I supposed to do? You can use FHIR messaging. I talked about that in an earlier session. That's a slightly different mechanism. You can have a trigger event that says, you're supposed to do it. But again, that's a layer around this service request. Or the final one, since we were going to look at a RESTful way of supporting workflow, is to use task. And task is the main workflow-oriented resource in FHIR. So if you're ever going to do workflow management in a RESTful context, task is the name of the game. I'll elaborate how that looks like. So tasks allows you to state things like workflow aspects, do this, or don't do this, I want to cancel this, okay, I don't want to do that. So it's kind of a workflow layer on top of the service request. It's separate from the service request itself. And it's a shared resource. So if you have an order management system, an ordering system, and a lab system, then this task thingy, this workflow controlling thing, sits in the middle and is manipulated by both systems. Physically, if you implement this, the task resource could exist on a separate FHIR server. It could be on the FHIR server of the lab. It could be on the FHIR server of the ordering party. But to our discussion here, that doesn't really matter that much. But there's flexibility in how you actually implement this. Okay, so FHIR resource model revisited. Yes, we have our service request. But the service request has, now in the middle, we have a task. Okay, and the task is related to the very same patient, obviously. And the task has a focus, kind of an input, which is the service request. And the task has an output, which is the observation that will finally be created as part of this workflow. Now, if you look at task itself, then it has a code to indicate the type of workflow that we're trying to initiate. And we see some status codes on there, for example, to see what the status of the workflow is. The task has a requester, okay, which is probably the same requester as the service request. I want you to do something and then also create the task. That's mostly the case. And we have the task can be claimed, can be owned by somebody who says, I'm going to do it. I'm claiming this task. I'm going to perform it, or I'm performing it. Now, given that task is about the status of the workflow, that means there's a whole state machine behind this task resource to ensure that you can express all sorts of workflow statuses. So here we have both the error statuses as well as the normal status changes for statuses in this task resource. And we see them color-coded, so a task can go from requested to accepted to in progress to completed. That will be a fairly normal life cycle for a workflow management resource. But you see that we can also have cancelled, rejected, or failed. Because let's revisit this workflow overview. Because if we're talking about order management, then it's not just pushing some FHIR resources around like service requests, we also have to deal with task. So actually what we're doing is adding another layer on top of this. We have the bare bones management of the service request and the lab result, but you have another layer on top of that for the management of the workflow aspect, the workflow management aspect. So the order placer that creates a service request also has to kick off the workflow by creating a task. Okay? And the laboratory is going to claim ownership of that particular task and informing the tracker also of the progress of that particular task resource. So actually, in this overview, we have the double layer in there, both the workflow management aspect as well as the simple service request lab result type of workflow. Now, I fully realize that all of this is relatively abstract. So let's have an example, using laboratory again, a multi-step example to show you how all of this would be supported using task. So we kick things off, step 1 of 6, so 5 steps to follow, by the placer system basically creating a new lab order. And what's the lab order? That's the workflow aspect as well as the service request aspect. So we have the service request here, and if you zoom in on that, we see that it has an identifier for the placer order number. It has a status that says active, which means this service request has not been done. It's an active service request. Okay. This is my original order. It's an order in the category laboratory, and I'm asking you to do a sodium test. Okay, it's a simple example. Plus, I'm going to create a task, and the task is basically, it's not a lot of detail in there. It basically says, well, it's a lab order and it's requested as a status. It's an open task that has not been claimed by anybody that they're actually going to do this. And all of that stuff is related to our patient Adam Everyman, and the task and the service request were requested by Dr. Hippocrates. It's our favorite clinician that we have in all presentations. It's nice to have Hippocrates himself, right? But anyway, so this is then available somewhere. So now the lab system could try and find out somehow that this particular unfulfilled request exists. So imagine if this task and perhaps this service request were, if you have multiple organizations, were on some centralized server, you would have to do some subscription or polling or whatever to try and find out, is there an open service request that I can actually perform? So that's the next step. Step number 2. The lab system needs to find out if there are tasks that they can claim. I want to do this. And it's sort of interesting if you have 5 different competing labs basically trying to find on the same server that, is there anything I can do? So every 5 milliseconds we fire off a query or whatever to find out if there is one. Hey, there's money in there, so hey, there you go. So how do you do that? Well, polling or subscription. And you see there's some search strings here. Okay? So yes, give me all tasks with the status is requested. In other words, they have not been claimed yet, that we have yet to initiate the workflow, which are orders and where the focus is a service request in the category laboratory. Hey, if I'm a laboratory system, I don't want to know about radiology orders, right? So that's where this category comes in. Or it could be simple, give me all stuff that's related to orders that were done by a certain organization. Or, and I've also seen this already, is that they used a FHIR operation on the centralized workflow server. Okay, if you have the centralized workflow server and you have these 5 competing laboratories, then you may wish to do a bit of load balancing, really. So that if you get a lot of requests from one lab and you go like, well, I have to be fair, maybe it's going to be 20% or something, maybe there is some rule, or I'm guessing that you already have enough of a workload. So if you are going to try and claim this, I'm going to refuse it. So there may be some additional logic to decide which of the labs, which of the parties you're actually going to allow to actually claim that particular task. Hence, an operation so you can hide that complex logic. Step number 3. So let's assume one of the laboratories has found out, okay, yes, so I'm willing to do this. And how do you indicate that? Well, you change the status of the task. Remember, that's the FHIR resource that's manipulated both by the ordering party as well as by the lab system. You change the status of the task to accepted, And then we have an owner, and in this case it's Dr. Klein, and Dr. Klein acts on behalf of, let's say, some laboratory department. We haven't done anything yet, it's just we've claimed the task. I promise that I will do this, effectively. So then, here we have the task again that we just saw. When I actually start doing something in the lab, I will change the status to in progress. I'm busy doing it, so that's one of the statuses that we have in the task, and that creates an observation. So here we see our sodium with 22 milligrams per deciliter, and it's a preliminary result. You quite often have that in lab results, that first we have preliminary results, then final results, and corrected results. So even within the observation we have multiple statuses. Now here, there's another twist here, because actually, if we as a lab system receive a lab order, that may actually force us to create another order, for example, to have somebody draw the specimen. But that's a normal business rule, that's a consequence of us receiving the order and there is no sample, so we got to have somebody write a small card through the hospital and actually collect the blood samples. But that's, as you can see, even another task if we're outsourcing that to some other party. Just to make things a bit more complex, otherwise it's too easy, right? Anyway, let's progress with that. So now we have the task has been completed, so the lab basically indicates in the centralized workflow task that we are completed. And what have we done? Well, here we have an observation. The observation has status final, so this is the finalized clinically validated result for our sodium 22 milligrams per deciliter performer Dr. Klein. Status is completed, but on the left-hand side we see our request still has status active. Because this system at this point in time doesn't actually know that the thing has been done. Because the ordering system has to look at the task to find out that there is a result. Right? So at some point in time, that system, the ordering system, will find out that the actual lab test has been done. So the final status here is that this system has found out that there is a result. So this one was completed, so now this one is also completed, and here we have a final lab result. Workflow done. Okay? So that's a 6-step kind of example of how this jointly managed task resource would be used. A few notes on lab result. Okay, it's about ordering and lab result. And two bits of terminology. In the laboratory space we have the concept of battery, sometimes called a panel. That's a predefined grouping of atomic lab tests. And you go, okay, say that again. Well, remember the paper order form that you have when people order lab tests? Okay, they started with those in the 70s and you scan them in the lab and then you have an electronic order. That's basically the whole idea. But when they started with this in the 70s, and pretty quickly they found out that people were always checking the same combination of boxes. If you want a white blood cell count, you probably also want to have a red blood cell count. Okay? So if you're always checking these 5 boxes, I might as well define another checkbox that if you check that, I will do 5 things. Right? That's a battery. It's a predefined grouping of atomic tests. And the other thing is the order group. If you're ordering multiple things, and actually each and every checkbox on this form, according to HL7 and also FHIR, is a separate service request. It's not one service request, the entire form. No, it's all separate service requests. Could be dozens of them on one form, right? But you want to somehow group them in some way that these were all on the same form. And why do you want to do that? Well, if you have checked 10 different things, you want to have one report that reports on these 10 different things. Right? So the expectation is, if I order this on one form, I want to have one result thing for the exact same things that I ordered. So hence you need to have this grouping mechanism also in FHIR. Now the grouping thing when it comes to results is diagnostic report. So besides observation, which you already saw, which is basically a code and a value, that's very easy, so very nice for my sodium, but not so nice for these panels. So if you want a diagnostic report, then that's a grouper of multiple observations. So effectively, you have a group of service requests, the form, the order form basically, and then you have one diagnostic report that's sort of the equivalent, conceptually, of this group of service requests. And the diagnostic report has a grouping of results, observations in it. Okay, so if we have here two service requests, okay, so we have a sodium and a CBC. A CBC is a panel, so that's multiple atomic observations. We have tasks for some laboratory to perform those, which lead to observations, and I will have a diagnostic report, okay, that basically speaks to all of these observations that were ordered and may actually involve the wider clinical context of the patient, so other different FHIR resources. You know, if the white blood cell count is dramatically low, but you know that the patient is taking chemotherapy, then obviously the white blood cell count being low is normal. Okay, so you need to take the wider clinical context into account, and that's exactly what a diagnostic report does. It's a grouper, but it's also summarizing and involving other information as well. So you're pretty sure to see this actually when you deal with lab order management. Now you may go like, well, this task was about nice, but couldn't they have done it differently? Well, there are other scenarios like this one, right? I'm going to create an order, and I'm going to request lab A. So I'm already assigning it to lab A. Lab A, you have to do this. I'm not waiting for them to claim it, I'm already assigning it to them. And then they go, no way. I don't have the resources. Okay, so I'm just going to change lab A, changes the status to rejected. Okay, and then they will find out, lab A doesn't want to do it. Okay, so I will just assign it to lab B. And fortunately, they changed the status to accepted. So you see that we have decoupled, if you want, the service request, because that doesn't change at all. I still want to have the same thing done. It hasn't been done yet. But the only thing I do is to kick off a new task to assign it to somebody else. Here we have a medication request cancel. So we have a prescription, which is also a kind of a service request, and we have the medication administration, and then we find out there is a problem. So the people who are administering the medication, they go like, well, we see that the patient is deteriorating, so we need to stop with the medication. Well, hey, they can actually modify the task to more or less inform everybody that, no, we're going to cancel this. Okay, and here we use the example of on the ICU, so the ICU can basically go like, no, we're going to stop this. You can also have it cancelled by a third party. This is a bit of a meta type of stuff, because I'm creating a task to request the ordering party to cancel that task. So I'm initiating a workflow to ask somebody to cancel another workflow. And you go like, is this used in production? Yes, this is heavily used in production as well. Okay, a referral. Well, what's a referral? A referral is basically another request. I want you to do something, which is to continue treatment of my patient, right? So a service request has a task and results ultimately in an encounter. So it's still the request event pattern that we talked about before. But if you have a referral, then you may actually wish to provide additional information. Like as we see here, the service request has supporting information, which could be the summary of our current encounter or something, because we want to inform the other system. And it could actually also be a questionnaire response. Because it could very well be that this party on the receiving side is only going to accept my referral if I supply a certain set of information or if I fill in a particular form. So the questionnaire response could be something that's supportive of my referral request. But just like anything, that referral request could be accepted or denied, effectively. So all of that, just to show you, it's not just about laboratory stuff, it's much wider than that. So to summarize, what you have seen is order communication and results reporting, request event pattern, use task explicitly capture the workflow status. As I mentioned, you can do it implicitly by talking to the receiving end out of band, using messaging, or use some other mechanism to do this. But if you do this in an explicit, restful way, task is the way to go, especially between organizations. That's really the only way to manage this. And obviously, diagnostic report comes out of our lab example to provide the context, the grouping, if you want, of multiple observations or imaging studies or whatever it may be that we have done as a result of the service request. So with that, you've hopefully seen and now you understand the highlights of the workflow management using REST, mainly using the task resource. But now it's up to the moderator to ask if there are any questions. Are there any questions?
Are there any questions?
Well, multiple. There you go.
Either way.
You're closest by.
Okay.
There you go.
So, René, this is really good, and I've got a bunch of questions. I'll try to narrow it down to a couple. And the reason
One.
yeah.
Got to be strict.
The reason I have, we're in the midst of discussing all this on a series of calls, the Orders and Observations Work Group on Friday, clinical order workflow calls for lab ordering and resulting, and you know, what you presented is very analogous, I think, to what we're talking about, but there are some little places where we may be a little different, and I'd be really curious to explore some of that further with you. But one thing I did notice, and I don't remember which slide number it is, but on one of the last few slides, you had the diagnostic report in there, but I didn't see, let's see, it's right, yeah, it's this one, yes. The one thing I don't see is that there's no errors, basically no connections from the diagnostic report to the observations, which are the results.
Yeah, I noticed that yesterday as well. So.
Yeah, okay.
My bad, yeah.
Okay, all right. And maybe if I can ask a little correlate question to that, so you'll fix that. But would you anticipate having, I mean, we're talking about the relationship of diagnostic report and observation, and I think many laboratories are thinking of always sending a diagnostic report, even if it's just a simple test like a sodium or something, but diagnostic report always being used not only if you're trying to group multiple results. And I don't know if you have any thought in particular about that, but I'll let you answer that, and then if I have time, I have other questions.
Well, there is lots of variability in how people use this, and obviously that's the nice point of FHIR, that there's lots of variability in there, so you need to profile it to actually make it implementable. But I can see that it would be attractive that you have consistency. I will always have a diagnostic report, and I don't care how many observations are in there. It could be 0, it could be 1, it could be 10,000, I don't care. I will also always use 1. So the direct equivalent of a service request or a group of service requests is always going to be 1 diagnostic report, however many observations that may be. I can see that. But especially if you're including other clinical information in your diagnostic report, not just a lab value, which is ultimately, to me, the aim of diagnostic report. It's not just a dumb grouper. It's also a summary over more than just the observations.
All right, who else had some questions?
But it will be interesting to learn in what direction the committee is going, Because obviously this is my interpretation and observation what I'm seeing, but that may be different of what the current thinking is. Sorry.
Yeah, thank you. From your perspective, what are the pros and cons about supporting this type of workflow with messaging and RESTful?
Well, purely from a workflow perspective, I think having a task in the middle is much more attractive than bouncing. In messaging, what you're effectively doing is I'm sending you my stuff, inclusive of my task information, implicit or explicit, to you. And then you do your thing, and when you're ready for a next step, you send me back your copy of the task, and which you have modified and added to, and then I will tweak it again. But in terms of provenance and tracking who has done what and what are the status changes, that's much more difficult to track in a messaging environment. If you have a simple thing like message do sodium, here's the result, well, who cares? That's trivial. It doesn't really matter that much. But if you have much more complex workflows, having the task in the middle, explicitly in the middle, managed by both, with provenance and tracking who's doing what to that task, gives you much more control. That will be my initial reaction to your question.
So my question has to do with the diagnostic report as well. And just a curiosity if you have noticed what works best between observation, has member, observation component, and use of diagnostic report, and which one you should use when, since they kind of all say the same thing a little bit in ways of grouping results.
Well, the easy answer would be go ask the committee for them to basically nudge them to include such guidance in the specification. I think they're well aware of this particular confusion. From what I've seen is that some people choose to do particularly batteries as components in observations, and others choose not to do so. So there is unfortunately no consistency that I've been able to detect. And as you well know, even in HL7 version 2, that's a bit of a nightmare. People are doing it differently. And sometimes, yeah, no, there is no real answer to that. But we can only hope for some best practice guidance from those that... there's some excellent workflow guidance already in the FHIR specification, but on this subject, I fully agree with you. The jury is still out on that one.
Hey, so I know in like lab ordering scenarios, there's often like secondary actors that are interested in the order beyond just the filler. So for example, if a blood culture is added, like an infection control system might want to get notified so they can verify precautionary isolation. Or like if a CDS hook service suggested the order in the first place, they want to know, was the order that I recommended placed, or was it altered by the physician before it was placed? How do those secondary recipients get notified in this concept? Because like in messaging, you just send the same message to all the recipients and they implicitly know what they want to do with it. Is the placer expected to manage tasks for all of those other secondary systems, or how would that work?
Well, I would, if it's just a notification, then I would basically go for a subscription type mechanism, so that the third party could implicitly or explicitly subscribe either to the task, or to them the task may not actually be that important. They may actually only be interested in the service request and the status thereof, or the observation, the resulting observation report. But it feels more like a notification type of thing. Related, although I'm deviating from your question, is quite often we have the order enters in the laboratory, but it's a specialized thing, so we outsource it again to yet another laboratory. But obviously that's just, to me, that's two different order or com workflows that have a relationship, but that's already covered. But that's a bit of a side thing derived from your question.
Hi, my name's Dave. For the task, I get the abstract concept here. One of the things I struggle with just mentally understanding it is the many EHRs have the notion of tasks that get assigned to human users and they're processing referrals and things like that. So are we actually seeing implementations take up this notion of the task? We do use it internally in Optum for a few things, but I haven't seen trading partners take that up. So can you speak to that at all?
Well, I've only mainly seen this really in these workflow management systems that sit between organizations effectively. So that's where I've seen most of the uptake. And then mostly in European programs, so I cannot even speak to experiences here in the US. So yeah, I cannot really tell you where this is used currently in the US, so if somebody knows, then they can speak to you over drinks, which is after this talk. So.
Is there any more questions? I think we have a couple of minutes left.
Things never change, René. So it feels a bit complex to me, but I know we're dealing with something that is complex. So I know something kind of important is, and I think you just left it out just for simplicity, when it comes to lab orders, we care a lot about specimen collection. You know, the effective time of specimen collection is really important.
I had specimen collection in there, so.
Okay, but is that done with the specimen resource or is it done somewhere else? It's done in the task? Okay, so in the task, because we care about, you know, did you collect the specimen yet? Who came up to, did we send someone up to collect the specimen? Did it collect it? Is it in the lab yet? Did it get to the lab is a big deal. So, depending. So that would all be done with task?
Good question. I don't know where specimen location would actually be specified in one of the FHIR resources. But certainly we do have specimen collection here with a separate task. And obviously all observations and service requests have a link to the specimen, so.
Because doctors look that up, like how is my test going? It depends whether you got the specimen, if it's moving.
Well, certainly in my diagram you can determine if there is a specimen. But where it physically is, that's a different question that I don't know off the top of my head. So.
Well, you know where the patient is when the specimen was collected. So.
Well, you know where the patient is when the specimen was collected. Let me repeat that. But. Well, actually, let's revisit that. In the task, you have a workflow status, but it's in two different levels. And I think one of the levels allows you to specify your own code for where you're at in your own workflow mechanism. So if in your workflow statuses, your own statuses, you have a code that says specimen in lab, then you can define that within the task itself that is the stage of your own workflow status transition. So that would be the way to solve it. Although there is a comment, so.
And I think we have time for one more question.
This is more of a comment than a question. Do you have time?
Well, there's 1 minute. If there are no questions, then let's. Can you bring the mic over here? Right.
Thanks, René. So, can you speak to where you have been seeing kind of like implementations of RESTful workflow task lab ordering? It sounded like you were referring to at least a couple over in Europe. Is that the case? And then is there architecture designed to kind of mirror the way in which you presented that central repository of orders?
I didn't catch the last question, but we can take that offline. But yeah, I know of a couple of projects that are actually using this. There is one system and lab vendor in Germany that's already exposing this. And I know of an implementation in Scandinavia where they're actually using this in a production setting. Yeah. But still, it's still relatively small. Because this is, as Virginia noted, this is a complex field. So people are hesitant to embrace this, but really, if you're doing order management over multiple organizations, you're going to end up with a relatively complex thing. There is no way around that.
So maybe I'll just add on with that, if folks are interested in further developing this guidance and kind of having some best practice recommendations for how this ought to be done in FHIR, if you wanted to join those calls on Fridays in the Orders and Observations Work Group, that input would be very welcome on that. We're trying to work through all of this and that. And one thing I was just going to mention on this, you mentioned the references on specimen and service requests and all that. We're actually at least considering removing the reference from service request to specimen, because we also have a reference from specimen back to service request, which is probably the proper way to do it in FHIR, since the service request typically comes before the specimen is collected. The specimen then should refer back to the service request. And right now we've got both pathways, and we actually can't come up with a good reason for the first one, so we're thinking about removing it.
Well, in version 2, we were trying to model the fact that you could have one request that had to be done on multiple specimen versus multiple requests that were all to be done on one specimen.
We've thought about that too.
So you have both use cases, hence the reference going two directions.
Probably we talk about that, but I probably don't need that, because if you like
But that's okay. We can just, that's the future direction, and you don't have a mic. So thanks everybody. It's an interesting topic, I hope, but you have hopefully understood the highlights of this. Okay, go play with that. You know who to talk to within HL7 if you want to drive this forward. Good luck with that and enjoy the rest of your conference.